morning, everyone. Thanks for joining me. Today we're going to be talking about machine learning, actually most of the day. We will do 3 sessions. This one is about introduction to machine learning on mobile. So as a mobile developer, what kind of terminology is out there, what to think about models, inference, what you can and cannot do on a mobile device. Again, this session is being live streamed on Twitch. Hello. And it'll be available later this afternoon or even this morning. So if you want to go back and review some of the content. And then if you provide feedback this afternoon or evening, then you'll get the slides, a PDF version of the slides available to you. So you can go and run through some of the demos. So again, my name is Dennis Hills, and I'm a mobile developer advocate at AWS. Been there 5.5 years. I'm based out of Seattle. So I'm here for 3 days, and you guys get to see my face for another day. So we're going to start out with the introduction. So as we go through, feel free to ask questions, or we'll talk about some real use cases instead of just like talking about what machine learning and cool stuff. We'll talk about like real implementation, like what's out there right now. And then yesterday we kind of touched on a little bit where a lot of these terminologies, a lot of these features of AI, machine learning, will be just normal for mobile developers to put into their apps, and users will start to expect that. You know, facial and text and all those kind of recognition. So, but I wanted to talk about the basic pieces of, you know, what AI, there's a lot of broad terms out there. Artificial intelligence is the broad term for applying any technique that enables computers to mimic human intelligence. So logic, if-then rules, decision trees. Sometimes it's very simple decision tree, and sometimes it's very complicated, deep into tons of deep learning and deep data and algorithms. But think about chatbots, robots, Kit from Knight Rider, if anybody remembers that, you know, autonomous vehicle kind of thing. And they're in use right now. We got drones, voice-driven interaction with Alexa, inventing entirely new experiences. So that's one of the things we talk about with the AWS Cloud is it's allowing new areas to explore, like, you know, the MLB app, the app bat things. We're collecting analytics and doing real-time streaming and real-time analytics. All that is capable with the cloud now. And we'll talk about why the voice is so huge, why text interaction, why machine learning is such a big deal right now. And there's some hype, but there's a reason for it, because it is becoming the norm. And then there'll be a time where, as mobile developers, we'll be able to just go in there and, you know, create these applications. And I'll show you a few applications real on my device that kind of demonstrate that, where it's real simple use cases. So machine learning is a subset of AI. So it's a set of methods that automatically detect patterns and then use those uncovered patterns to predict future data. So when we talk about, there's 3 areas of the machine learning that we'll talk about. One is the supervised piece, which we're really just taking a bunch of data, labeled data, like as a teacher, we're labeling all this data, sending it to the computer, and then analyzing it, and then saying, okay, this is a shirt, this is a shoe, whatever it might be, and then building out a model. This model is the brains of everything. And so we train that model in the cloud and then bring it to the device. And then we give it real-world shoes that it hasn't been tested on. And it predicts whether it's a type of shoe, whether it's a shirt, whatever. You've seen it before in different areas. Recognition does this well with tagging. You send it a picture, and it'll tell you if it's a sunset. It'll tell you if there's chairs, tables, objects, people, whatever it might be. So that's the idea, is you're training this model as much as data as you can give it with labels, and then you take out the real world and you start giving it items, stuff, and it gives you answers for that data. So it tries to do a prediction. And then you can get as accurate as you want. Usually the larger the model, the more accurate. So you get some examples of the personalized recommendation. So you start collecting data like where people go, where they travel, all the analytics about their use cases. Fulfillment automation, inventory management, so they could figure out exactly where to be inside the fulfillment management. And then that's a big one right now, is the shopping. You know, try to understand trends, what the prediction, what those users have purchased in the past, what they're wearing, what they're going to buy. It happened to me recently. I was on Amazon and I just bought something, a shirt, and I was like, oh, and then next day it gave me a recommendation of that shirt. So it's sort of algorithm behind the scenes, and a lot of that's just putting all the data together, collecting all the information from me and what's available, what's out there, and my buying trends, and then present that to you. As a mobile developer, we could take advantage of that in different ways and present that to our users. So some more definitions. It's all about data to answer questions. First data, so image, text, voice. Think about all the voice samples you could send it, like where you could repeat somebody's voice or mimic somebody's voice. You could just send a bunch of voice clips and it could learn on who's that voice, the name of that voice. Same thing with objects, everything else. You're teaching that model, and then later we're trying to make predictions on what we're sending to that model, and it's going to say, okay, yes or no, or 80%, 70%. And we'll show what that looks like. So important limitations for mobile. So mobile apps pre-trained models. So we talked about this model, we train, and we give it all the answers there, and then we put on a device, and the device is doing predictions. So there's two pieces to machine learning. There's the training of this model, right? We send a bunch of data. Typically, that's done in the cloud. So when we say machine learning on the edge, it's not necessarily training the model. So that one thing I want to go away with today is when we're talking about machine learning on the mobile device, it's the inference or the prediction of a model that's pre-trained in the cloud typically. So there's a few use cases where you could actually do the machine learning on the mobile device. But that's a limitation right now. You can't do the learning on the device itself. It's just not powerful enough. But again, there's a few edge cases there. So we're taking this model that's pre-built or pre-configured in the cloud, and then we're taking it and we're doing predictions. So typical example of all those items we talked about, we train the model. Then we take our camera, we take a picture of it, immediately goes into that model and gives us a prediction of what that device or what that object is. Does that make sense? So we're talking about machine learning on mobile. We're talking about inference and prediction based on a pre-trained model. Okay, so I'm going to talk about three things about why all the hype and the differences of what makes a difference in between the last 2 years of why we're seeing all this Alexa, why we're seeing chatbots, why we're seeing this vision technology, animojis. Several developments in the world of ML are creating an exciting playing field for mobile developers. So advances in neural networks. So we're not going to go into deep dive in neural networks, but there's a lot of advancements in dramatically improving the accuracy and recognizing images and speech. Speech is one of the big ones, right? Because speech has been around forever. Speech recognition, we got Dragon Speak, we got a lot of those features of software, but it just hasn't been predictable, accurate. And so when we start getting into the 85, 90% accuracy rate and far field like Alexa, I could be like, Alexa, tell me what time it is going to be tomorrow. And she could pick it up and understand my voice. And a lot of people, there's dialects and all that, but several years ago, that wasn't a possibility. So now we've taken that and put it on the mobile device. So now we have that accuracy that allows us to add those speech mechanisms to there. So all the time we're talking about API gateway, and GraphQL and endpoints, and then we're putting an interface, a touch interface. That's why we're starting to see more voice interaction apps out there. So instead of touching and playing with your app and visually looking at it, you can interact with all those pieces with just your voice. So that's where we're talking about the chatbots or just a simple navigation control on your phone, or like what time it is, and you're starting to see that with Siri shortcuts in some of those cases. So it's about the algorithms that's kind of the accuracy in the images and the accuracy in the text and voice. That's the big deal. So advances in cloud computing. So a lot of these algorithms are not that smart, and what they need is this massive compute power. And so before we didn't have the compute power, it was very costly to go in there. And now with the cloud computing, things that we were taking weeks now take hours or minutes. So that's a big deal in the last several years is we've been able to take this large amount of data and then go and train this model. And when it took weeks, you have to keep reiterating and go through, okay, we got to train this again, we got to go back to the drawing board, another 2 weeks, go back again. Now if we're talking hours, so all these institutions, everybody could train and then figure out the results and say, okay, we have an accurate model, let's go and deploy it. And so that's been changed a lot as the cloud computing across the board has the GPUs spinning up and then only pay for what you use and then just spin it down. So a lot of the institutions will grab the big giant GPUs and then just do a lot of calculations, train that model in minutes or hours, and then shut it all down, analyze the data, and then start right back up again. There's also been a flood of third-party API and machine learning services hitting the market. So a lot of that heavy lifting is done for you, and we'll talk about, I think that one, we'll talk about the next one, maybe a little bit today in this one, but Recognition, Poly, Lex, those are managed machine learning services that have done a lot of this work for you. So Recognition is a good example where we talked about training a model. They already have this model that has object detection. So they've been trained on thousands, hundreds of thousands of objects. And so when you send those images to recognition via an API call, it already knows it and tags, and then they're constantly iterating through those models. But if you were going to do that on the edge, you could actually, behind the scenes, train your own model just like recognition, and then bring that to the device, and then every time you take a picture of something, it'll go to the device and stay locally. That's when we talk about edge computing, is having that model on the device itself. So I'll talk about the three types briefly, just because these are the areas that you'll hear about when they talk about machine learning. Unsupervised and reinforcement I won't talk about. Those are kind of the more advanced topics, but the more common one is that supervised learning. Think about supervised again, is you're teaching it. You're a teacher, you're taking this model, and it's a little baby, and you're giving it a bunch of data and labels. So say this is a chair, these are all different types of chairs, you're labeled it with chair, tables, whatever it might be, faces, and you're training that model in that supervised learning, so that when that model goes out in the wild, it's going to make predictions on what it sees in the real world that it hasn't been trained on. So that's the idea, is you want to be able to identify objects that it hasn't been trained on. A good example is dogs. You could send it thousands of dog breeds and dogs that you go to the dog park, and you look at it and it'll tell you if that's a poodle or if that's a Rottweiler or something. In a lot of cases, it'll look at and see wildlife as well. You'll be able to see if it's a deer or if it's an antelope, and vice versa. So supervised system of labeled predicted model. So we use the label data to train the model, then use that model to make predictions. So you'll either hear predictions or inference. And basically says, okay, I think I know what it is. I'm about 80% sure. And that's what the model's going to tell you. And then you can say, okay, great. And then you can increase that accuracy depending on how accurate you want it to be. If it's just regular to everyday objects, then it's not that big of a deal. So the trained model is the core of discussion when it comes to machine learning on a mobile device. We're talking about this model that we're training in the cloud and putting on a device. I think I've repeated that 3 or 4 times, but I want to make sure that's clear when we go and talk about machine learning on the device, so we kind of know that when we talk about demos or use cases, we'll have an idea of what we're doing. So get started. So we know why it's being used and what problems it can solve, but what does that really mean for the mobile developer? So there's 2 areas that have allowed our iOS devices and Android devices to do machine learning. Remember, machine learning on the edge. So CoreML is now the new framework to use, and all it does is takes that model, you have a CoreML formatted model on the device, and then it interacts with anything with text, voice, objects, whatever it might be, and that does the prediction itself. So that's the power of it. It's been around for like a couple years now, but before that there was other frameworks, but CoreML has made it super easy to interact with the camera, interact with the actual frameworks of the Apple device. And then Android, the same thing with TensorFlow Lite. So you build the model, and it's got to be in a TensorFlow Lite model type, and then TensorFlow will take care of all the details about pulling information and doing that prediction for you on an Android device. So when you hear about CoreML and TensorFlow Lite, those are the frameworks for doing machine learning at the edge on those devices. And I'll do an example at the end. I'll show you an app that we put a CoreML model in there that's been trained. It's a 100 meg model that's been trained on a ResNet, like 100,000 objects, and I'll show you what that looks like on the device. So then you maybe ask, we talk about cross-platform a lot around here. So why not TensorFlow Lite on Android and iOS? And in this case, use the best tool for the job. A lot of cases, people try to force, cross-platform. And in some cases, it might be you have a really nice framework that you can do. But in this case, if you're going to do Android, start with TensorFlow Lite. And then if you're going to do iOS, do CoreML. Yeah? Yeah. That's a good question. So she's talking about putting the model on the device, and with 2 different frameworks being TensorFlow Lite and CoreML, we're going to have different predictions. So the idea is that we're going to have the best of both worlds. So the model is the core, right? So we trained it in the cloud, and then when we transfer it to the device, we convert it to that format. It still has all the prediction, all the same value, the same smarts. It's just a little different format. That's all it is. So we're training the model in the cloud, and we're using the same model, and we're putting it on an Android device, and then it's going to do prediction with TensorFlow Lite. We take that same model, convert it to CoreML, put it on the iOS device, and then using the CoreML framework to make that prediction. And it's ideally...
Question on the live stream.
Oh, there's a question on live stream? Okay. And ideally, you would have the same accuracy. Yeah. Let's see what we have. Hold on. Let me pull up that. Does that make sense? So the question was, do you believe that mobile devices will ever have the power necessary to do training of models? It's a big question. And yes, like the advances of the iPhone and new Android devices, yes, I think it's going to be capable of doing smaller jobs, like text-based, smaller images, small use cases where we'll be able to do predictions on, on a personal side of things, and we'll still have accuracy. So I think that's a possibility. But remember, we talked about yesterday in the introduction to mobile development, when we talk about TensorFlow Lite, especially with Android. So as devices get better and faster, the Android ecosystem, the users are not adopting it as fast as like the iOS. So iOS, like, we're 2 or 3 years old. But when we talk about Android, anything that's like over 2 years old isn't going to be able to do any kind of machine learning on the device itself. But as we see next year, we'll see some newer devices for Android. But then again, we're talking less than 5% of the user adoption. So that's something to think about when we talk about different platforms. So yeah, that's a really good question. So I think that's going to be a possibility that we'll be able to have machine learning actually training on the device itself. So imagine a little baby sitting between the two icons. The baby's the machine learning model, and they both have in common. Sort of goes back with your question of this model is still the same. It's just in a different format that they both talk to, and it's all done. So the baby analogy. Okay, so I'm going to run through a quick demo or a few demos just to show you some use cases. So I'm going to run through my app real quick to show. See what that looks like here. Okay, so the first one I want to show you is the CoreML piece. So what I've done here is this is a project that's provided by Apple. And can you guys see that? So if you see at the bottom of the screen, you can see how it's doing real-time prediction. So there's some accuracy to this, and sometimes it's not real accurate. But like you have, I don't know, this carton, barbershop, like I think it picks up shoes, punching bag. What? Let's see if it picks up the cup. Carton, maybe. Is it a hand? So let's see if it picks up notebook, computer, desktop. Let's see if it picks up a desk, filing cabinet. If it picks up chair, printer. There's no printer there. So what this is a CoreML model. It's there's a few industries out there that have created this model in the cloud. So this is a 100 meg file or model that is CoreML format. And so I put it on the device, built it and ran the device, and I'm using the CoreML framework to do real-time prediction on what it sees. So this is the value of the edge computing. When we talk about, you know how we talked about recognition, right? When you send an API call, you have to send an image out, and then it comes back with the tags. So the power now is in our hands with the edge computing. So we have this device here, and I have this 100 meg file that can recognize thousands of images, and I could set that threshold. Remember I talked about prediction? I could set that threshold to say like 95%. You've got to be sure that this is the shoe, or 98%, and then just like narrow it down. Now this is a big generic model with thousands of objects, but we had a gentleman here yesterday. We were talking about identifying items in a refrigerator. So the narrower scope you have, and the more images of those narrowed scope, the more accurate that model can be. So this has just kind of the broad term of all these various in-room objects. But you can see that everything's being sent to that model real time, super fast, milliseconds, no latency. There's no network. I can be completely offline. And so a lot of use cases for this is like when you create a lighter. When you create this app and you want to do, like, we have, there's apps out there in the farms that are not connected to the internet, IoT devices in farms to collecting all this data, and like farmers can take pictures of their plantations, you know, of leaves, and it'll tell them if it's rotten or if there's a disease or what type of disease. Because somebody has trained that model and said, we're going to take thousands of pictures of a diseased plantation or some kind of a cocoa plant or a banana plant. And we'll take this and all these images and then take that back. And so the farmer just has this app, and you go around and take these pictures and instantly get feedback without being online. And so it's nice because you have the privacy because you're not sending any data back to the cloud. You're able to do real-time prediction, and then it allows us to do newer features like AR. So imagine how fast that is. Now we could just go around and identify objects and put text on those objects as we go around. If you've seen that before in some of the real-time identification, like when we're doing football, I think they do it in baseball, where they show the players and their names as they're going across. That's what it's using. It's using the face detection, knows who that person is, recognition, and then it's following them along in that video in real time and providing that feature. Yeah. So if you want to train the model, the biggest restriction here is the GPU. You got to have GPU to train a model. And now the devices can utilize the GPU. In fact, the newer devices, CoreML, does utilize the GPU on the device itself, but not a powerful GPU like we're talking about. Remember, these are dumb algorithms that are just go in there and it sucks up all that GPU. Just like, you know, SQL will suck up all the CPU. As much as you're going to give it, it'll take it. So that's the idea, is like, that's the restriction with mobile, is being able to, you know, utilize what you have, but you don't have the GPU, and that's the biggest issue with the actual training of the model. But now when you're trying to do the prediction, CPU is fine, especially the multi-core CPUs on these newer devices. They can do it really fast.
So mainly the main bottleneck here is any use case where you're going to actually try to do training on the edge. That would be the bottleneck. But if you're already just handing off a fully trained model and executable, then you should be okay.
Yeah.
Like, there's not too many bottlenecks on that.
Right. Right. Yeah, and then it's like this model could run on some older devices. Like if I have an iPhone 5, I should be able to run this just fine. It may be a little bit slower, the latency. The same thing for older Android devices with TensorFlow Lite. Those should be fine, just running those applications. And again, it depends on how fast you want to send all the information to the model, but as you can see, that one was just like spewing out data as fast as you can. And then you can actually have business logic in there, like filter out anything that's not, you know, anything above 85%. Yeah, and then, so that's great because those were generic objects, but we're talking about now we can custom anything. So if anything you want to identify, because that's what mobile's about, right? We're mobile, we got these cameras at the ready, we could take anything and identify it. So if we have this custom model, which like we're talking about dogs, we talked about refrigerator contents, whatever it might be, you build that model and you bring it onto the device. Now the other use case is where it's kind of a mixing of on the edge, is anybody have the security camera that identifies members of the family or dogs? Have you seen that? So there's several out there, and that'll become the norm. Remember, we talked about this normal thing. You got a webcam or your security cam, and it's like, okay. But now they're all going to have this feature, which allows you to send pictures or videos of your family, your dog, everything else, and identify them by name, because it's supervised learning. So what they're doing is they're taking all the information, using supervised learning, training a model on that device, and then now when that something's triggered, it knows if it's the dog, it knows if your son, their daughter, your wife, whatever it is. And then if it knows if it's not recognizing the family, then send me an alert. So now we're taking just a regular security camera feature and enhanced a lot, because now we can say, okay, only send me alerts if it's nobody in my family. Or only send me alerts if it's somebody in my family and not the dog, something like that. Yeah.
But the models are trained in the device, or just the model trained and it's put into the device?
Yeah, and the security ones, I don't know. I mean, I don't give the details, but that's where it kind of a mix. That maybe they send it in the cloud or they update. Like, anybody heard of Deep Lens? So we have a Deep Lens. So basically, think about Deep Lens, where the model actually is on the device. But you send all that data and it goes to the cloud, computes, comes back, and the model's there. So essentially, like if you're talking about family members, let's say 5, 6 family members, a few dogs, some cats, some parrots, whatever. We're talking a small model, right? Maybe 150, 200 pictures of each person or each object, and then you can send it there. So it's a pretty easy train. So they could either go to the cloud, do it, build it in, in one of their cloud computes in the GPU, and then quickly send it back, and it's a small size model. Or they could probably do it on the device itself and then do it in a small case, where they have it's not necessarily a mobile device, but it's an IoT device that has maybe a GPU built in. Yeah.
And that sort of segues into my question, which is the deep lens.
Mm-hmm. Yeah.
Deployment of the model.
Yep.
It's a little difficult sometimes to register the device to get set up. It'd be nice to see if you could do that, let's say, for an iOS device through Bluetooth, to be able to work with deep lens or manage your IoT devices. Do you see anything like that going on at Amazon? As that third tier of deploying models?
Yeah, so the question was about green grass, putting green grass on the device itself or interacting with other.
Before you interact, it'd be nice if, for example, deep lens had Bluetooth.
Yeah.
So you set it up and
Yeah.
you could do it through your AWS.
Yes. And yes, Deep Lens was just announced last year at reInvent. So, and I'm sure they'll iterate through that and be able to connect into, we're getting feedback from users about setting up, make it a little bit easier. Always room for improvement of improving that. But yes, I'd like to see the same situation with mobile, be able to send that information out to a managed service, right? And that managed service will come back with a nice model for me to deploy to my device. Whether it's Greengrass or whether it's some other framework, it's fine with me. But as a mobile developer, I just need to get that data, train it easily, and get on the device. We're not quite there yet because we have to go to like SageMaker, we have to train the model, GPUs, pull the data in, train it, and then convert it to all these different formats where Deep Lens does that for us. Deep Lens literally just say, okay, I have a cam and I want to identify all the wildlife. I want to say this is a bear, the difference between a bear and a deer, go. And it builds this model, comes back, and you have this custom model. Behind the scenes, it's doing some really cool stuff, but we want that for mobile. And I think that'll be coming down the road and in the future where we'll be able to manage that, use the cloud compute, and come back and have that model on the edge. Does that make sense? Yeah, so that I would like to see that too. Yeah.
So the demo which you demonstrated, are you going to show how that model was trained and where it was trained and how it reported to?
No. So he's actually about the model. How was that trained? How was that built? And I will go, I think I have in the next talk, the 4 ways to do machine learning on mobile. I have a few slides on SageMaker. So SageMaker, there's several ways to train a model. I could just talk about briefly, but the model needs GPU. And so with the model, and it needs, like, let's say you're doing object recognition or images. So you would send images to S3 or store it in somewhere, and then you would set up these GPU computes that you would use any type of algorithm that you want, and then it would build it and train it, kind of go through, and then have some test images to test it and say make sure it's accurate, and then at a certain point everything's done, and then you pull and extract that model and convert it to the format you want. So that's the process. And it's not that difficult to set up, but it's a little bit time consuming to set up because it's a lot of code you'll see Python. Python is ruling the machine learning world. So if you maybe want to learn a little bit of Python, a little bit of scripting, not that much, and then learn which framework you want to use, like TensorFlow Lite's really big, MXNet, and then there's Turi, Create. And then there's other parties. The other reason why it's going to be more popular, more common for mobile developers is we're seeing like Create ML from Apple. They announced at WWDC this year. And if you have a Mojave operating system, then you literally just throw a bunch of images in there of all your family and everything, and then it just computes the model in CoreML format. You drag it over on the device. So in a small case, we're using the desktop Mojave and using CreateML, and that's doing the machine learning. So that's super powerful, and that's available now with Mojave. So you can do that and we take pictures of each other. Usually it needs a lot, so there's a trick to getting images of somebody maybe doing like a 5 or 7 second video, and then do an FFmpeg or something and convert that into 100 to 300 images of that person, different angles. And then you send that to CreateML, and it computes right there on the PC and runs through. And the more GPU or the more power your notebook has, then the faster it's going to be. And like you said, in small cases, you got 10, 20, 30 people. I'm going to do my coworkers, so I can identify coworkers as I'm walking down the hall and identify them by their name. But yeah, it's there, but it's just that bringing the tool set available to us and the different cloud providers to create that connection between the mobile device and this big GPU stuff. The what?
I knew about this Mojave
Oh, sorry.
and the CreateML.
Yeah. So Apple has created, and again, that's just for that specific platform for iOS. So it has Mojave. That's the new operating system for Mac. So it just came out. I think it's made a beta. Maybe it's out now. So Mojave is the new one. High Sierra is, I think, the current one. So Mojave, if you install Mojave on a notebook, on a newer notebook, and CreateML is one of the features, the frameworks on that operating system that allows you to open up Xcode or Playground and actually say, I want to create a machine learning model, right? Take the model, and I want to throw a bunch of objects in. And so basically take a folder of Dennis and 100 images of me, 100 images of my dog, or 250 images of my wife, and label it and send it to CreateML, and it creates a model for you. And so now the next time it goes and gets a picture of my wife at a different angle, whatever, it'll identify her. And that's the idea of making it super easy and compared to like sending all that information to the cloud and building out the Python scripts. Right, yeah, no Python coding, no nothing, yeah.
It's going to be based on the image processing? Just images?
Most of it's image, yeah. And we're talking about, when supervised learning, we're talking about image, text, and voice, but the most popular right now is the image detection and recognition. Sorry. So, yeah, so there's other cloud providers that offer for Android that I won't talk about, but yeah, there's other pieces where they've just made a framework, a little bit easier layer to create that model for you, and then it'll create it in the TensorFlow Lite model for you to put on the Android device. Yeah. So in SageMaker, you would train a TensorFlow model or train it in anything really, and then convert it to TensorFlow Lite. So you could do kind of anything that you're used to, like any of the frameworks that's available, the MXNet we talked about, all those, and then you can actually create it, and then you convert it into the TensorFlow Lite model, which is still same model, it's just a different format from what the framework's looking for when it does the prediction. Yeah.
Just wondering, if we have access to those labs, how to build your test application on our phone.
Oh, to build it, yeah, and I could provide. I'll provide a link in the slides. They're just demos from Apple, and they just say, okay, here, download this app, and then it's a 100 meg file that is the model, and you can download the models from anywhere. Yeah. Yep.
The traditional approach is that we put the model in the cloud, and mobile communicate with the cloud, and then now we move down that model to your mobile.
Yeah.
And compute done. Rather than processing power and all those things are downgrade. Even though we do the communication part, there are some other parts that we. So then my question is, what's the advantage you move down everything to the mobile device, and everything? What's the advantage you can get from that?
So the question was, what's, with the approach where we could have a model in the cloud and connect to it with API, and then what's the advantage of putting the model on the device itself? That's a very good question. And I don't have the slide. I think the next one I talk about when I talk about edge, we have security. So security where you don't have to send images if you're using sensitive data. So the data goes straight from the device to the model on the local device. No API calls, so it doesn't cost anything, right? So you have the privacy, and you have no network connection, so you don't have to be, you can be completely offline. It could work in subways, it could work on airplane mode, whatever. So those are the three biggest advantages. And the other one is the real time. I mean, if you really want to analyze things in real time, like traffic analysis, if you're doing object detection really fast. So imagine if you're doing like celebrity recognition. We just created an app of celebrity recognition. And I wanted to go and I'm walking down Rodeo Drive and I want to identify celebrities, right? So right now, if I was going to use an API call and I don't have anything on my device, I would be like this. It would be like taking a picture every maybe 3 seconds of all the faces, sending it back to recognition, API call, return, return, return. Boom, we got a match, bing. Okay, got it. Not real efficient. But if we had that model of like 200,000 celebrities, A, B celebrities on our device, train the model, then in real time we could just have a chest cam, a webcam, and we could be walking by and then bam, 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 real time. Nope, 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 nope. And imagine like the police force wearing something like that, like, you know, victims or suspects, and they could just scan in real time. So you've got to have that model on a device if you want to be able to detect and recognize in real time. Otherwise, you're sending that API call back and forth. So does that make sense? That's the value of putting it on the edge. Those 3 or 4 things that are just really powerful. So yeah, I guess it depends on your use cases, how big of the model is going to be, how accurate you want it to have on the device, what devices are capable of. So like if you're developing for Android and we have, you know, a model that's a little bit compute power, then it may only work on certain devices. Like TensorFlow Lite, I can't remember the API limit. Maybe Adrian can help out on here, but I can't remember the API limit on running TensorFlow Lite. But it's like one of those the list of like a 1-year-old or 2-year-old operating system. And remember, anything older than 2 years for an operating system is like less than 50% of the Android users. So it still has required a little bit of more of a newer operating system and newer devices to be able to at least do that prediction. Again, if you're doing a small, really use cases, it could be valuable. But you could do it as small as you want, just like I said, per family, per user. And both platforms allow you to create these models in the cloud and then put them on the device without releasing to the App Store. So that's a big deal. So they've realized, like, if you have a small amount of data, let's say, you know, a 1 or 2 meg model that has just family members, you can actually train it on a daily basis or certain objects. You can actually train it on a daily basis by sending information back to the cloud. We could train the model really quick and then do a stream to that object through a silent push notification to the device so it automatically is updated. So you could do it daily, weekly, so that user has a custom model unique to them on a weekly or daily basis if you need to. So that's an option. So you're not limited there with like going to the App Store, waiting 24, 48 hours or a week to deploy a new model. Yeah.
I know that right now from Lite in iOS and Android, there are models that are working right now, like speech to text and text to speech. But my question is, those models are available to use in other contexts different to mobile or not?
For the what, text to speech?
Yeah, with speech to text, for example.
Well, they could be used outside of mobile, like the desktop app. Is that what you're saying? Like, so yeah, we could use the speech to text, text to speech anywhere on a mobile device, on the desktop, web browser, wherever it might be, or like, you know, Alexa device where we have it just on an IoT device.
But it is connecting to backend server, right? So what his question is,
Yeah, because it's
on edge, model should be on edge, I should be offline, and if I take a picture, you should tell me what is text.
Yes.
That kind of thing.
Yeah. Yes. Yeah, and so that's when I talk about in the next talk, we're going to talk about using the APIs like speech is a really good example. So when we talked earlier, we were talking about images and putting in a model, but yeah, you can do speech recognition and build this model out. Like Apple provides and Android provides this, where we can actually use the speech, which we'll do the workshop in. We're going to use the Apple API, speech API that's built in, has the model, it's already done, it's already on the device, it's part of the operating system. And then when we use it, we could just speak, and then also it'll just recognize our voice and then translate that to text. And so that model's already built into the system, and that's on the edge. We haven't trained anything, but it knows our voice and it translates to text. So then in that case, instead of using like Lex, we can take advantage of the edge, which we could do all this voice, and it's very accurate, and then we send that text to the cloud if we wanted to. So like we use Poly. You know, Poly is the text to voice. So if we don't have a framework that's text to voice on the device itself, then let's use Poly. And that's where we're talking about whether we go from edge or we go from an API call for a managed service. And that's what we'll talk about with Poly and Lex and when to use those and when to not, and taking advantage of the power and decide what's best for your use case. And it just depends on how you want to do it. So you could take the route of like customization, or you can just simply make an API call to recognition. Now, a lot of things recognition is great, but again, it's not real time, it's not on the edge, and it's only the objects that it's been trained on, right? So if you want to train it on certain facial features, certain glasses, whatever it might be, then you'd want to create a nice custom model and put it on the device. Yeah. Does that make sense? Yeah.
Well, the Alexa device, is the voice recognition on the device or is it on the cloud?
It's on the device. Yep. And then it sends it back in. So it's always listening, and then the same thing we can do with the devices. So with the speech API I was talking about with Apple, I could just turn it on, and it could be just listening for anything. I could just be talking, and then if I say poop, it'll all of a sudden send that poop to the cloud and then do something. So all it is keyword recognition. So now we've had this accurate of speech recognition. Now we could do anything with our phone, and we could actually say cheese. It'll take a picture. We could say send this to my wife, whatever, and then it'll just take that voice, and you're looking for those keywords. So it's constantly listening and using the same thing. And then Alexa has the more powerful, the far end and the different microphones, but the idea is the same. Yeah. Alexa, no, Alexa can't. Yeah, Alexa. Yeah, I haven't tried to disconnect and then see if it recognizes your voice. It'll say, I think if you disconnect a Alexa device, you could talk to it, and it'll say, I can't do much for you. Yeah. So Alexa, by the way, is just the voice recognition, right? And then it translates your voice to text and then sends the text to your server, which is typically a Lambda function. That's all it is. Well, it sends speech or, MP3, binary, streaming audio, whatever it is. Yeah, it could do whatever. Yeah. I don't know exact terminology if it's just actually text or the voice, but it has to convert those into words and then make that command.
Just want to clear it up. So on the device, it's always listening to which word, right? So Alexa is always listening to that on the device. But like, let's say I give it a command. Is that also on the device translated to text, or is that whole speech, like you said, is that whole MP3 or whatever the speech is sent?
You talking about Alexa? Yeah, I don't know about the details on Alexa, but I just know it's listening for that keyword. Whatever you have, Amazon, Alexa, and then there's like Echo. Yeah, and all it is so it's listening, and then it just kind of doesn't do anything, and doesn't send anything to the cloud until it actually hears that keyword. And the same thing you do with the Apple or the Android speech recognition. On the device, it's all it is listening, and then it's waiting for that keyword. And I'm talking, Alexa, boom, and then it picks up. And then it translates, it takes to Alexa, yeah, and then it does something, and then sends it to the cloud if it needs to. Right. Yeah. And maybe eventually, it'll have more compute there, and maybe it'll have a model on the device itself and be able to do things, like what we would do with Deep Lens. So combination of voice interaction with images too. So there's a lot of possibilities there. And so, yeah, so we talked about the webcam, the security cam was another example. And then text, we haven't talked much about text, but you see it a lot. Google, anybody use the new Gmail feature where the text ahead kind of thing, predicting? Pretty cool, very powerful, but kind of creepy. Or have you ever said like, hey, you send an email and you say, hey, see attachment. I mean, this is technically machine learning, but it's, it's a real simple form. But if you say, hey, see attachment, and then you hit send, and then Google will say, whoa, you said attachment, but there's no attachment. Kind of creepy, but great because it's like nice. And then the same thing where I was just using Concur app and I was doing expenses and I was able to say, and it knew what I put in previously, so it kind of keeps track of that. And then Apple is continuously doing that with their text ahead. When you're texting things, it'll tell you if you've been talking about a certain topic or subject. It'll pick up on that and understand, like, okay, it knew that you were doing something, and then you can search by it. All those kind of things. It's kind of doing a little bit of machine learning, and actually might be doing it on the device. I don't know. So Apple is doing that right now, and that's when I talked about being the norm. So we have like chat apps, and we have photo sharing apps all over, right? Hundreds of them. So that'll become the norm, is to be able to stand out, is to be able to say, like, okay, let's do a chat app. But let's try to do some text prediction or text recognition, so where we could pick out entities out of there, tokenize those words a little bit, and actually use them so that the users can type really fast, or putting a simple microphone or voice interaction to that, and be able to talk to it, and then turn that into a text and then send that chat. Or with the photo sharing is another big one. Like anybody on iOS 12 has the new feature. Androids might have already had it for a while. But in iOS 12 now, it knows who my family members are, and it says, okay, great, so now I can go and search for the region. I can go search for like my son if I want to see all the pictures of my boy. His name is Iron, and it says, okay, it knows who it is because I've labeled him at one time. It was Learn, and then now I'd search for Iron, and it shows me all the pictures of Iron that I have on my device, right? So as a mobile developer, we create these features. We say, okay, well, let's do a photo sharing. We'll set quota. We'll sell this this app. But then what you want to do is make sure you add these kind of features to enhance it and stand out above all the other apps out there that do file sharing. So that's it for the introduction. Then the next one we'll talk about 4 ways. So we'll talk about a little bit about using the edge use cases. We'll take some business logic and figure out, like, do we call the API, the managed APIs, the 4 different ways we talk about of machine learning. So that's really fun because then you kind of like play with the different ideas and then see which one works best, or use a combination. Then the talk after lunch, we're going to do a speech translator, which will use a combination of the framework API, which is the machine learning, the voice recognition. Then it's going to go into translate, and then it'll translate that text into a language of our choice and then speak back to us via Poly, so the managed service. And a lot of these managed services, like you said, the typical use case you call API, very fast, very low latency, and just like super fast, where I could do a translate app and it could translate on the fly and I'm anywhere, and it's useful and relevant and fast. And I don't have any compute on the device itself. It's just simply making API calls. So we'll talk about that throughout the this morning, and then the workshop at 1 o'clock. So any other questions? Let me check online real quick, see if there's any questions. Nothing. All right, so we'll break, and then we'll come back in 10 minutes, and we'll start the next session.